All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at part 3 of our notes, analyzing functions and from their graphs. So when we interpret the graph here, so check this out. This is part 3 here. Now there's a little typo here or copy error. This piece right here, I'm going to highlight it. That little bugger, that should have been actually over here. So I don't know why, copying, whatever. So that should be like this. So just ignore that part. It's not a point. It just should have been over on that other side. So let's be sure to check that. Now we're going to analyze g of x on all of these different things. So let's just kind of go through and we'll just start with part A. What's a domain? Now, a domain, remember, that deals with the x value. So I start right here at this x value, and I want to write the coordinates of the point there. So that is 1, 2, 3, 4, 5, 6. So negative 6, and then I go up 1, 2, 3, 4, 5. So that's the point negative 6, 5. So I'm going to start from negative 6, and I'm going to go from there all the way over to this side. But notice, since this keeps going up, that means my x's are going to continue to go to the right. So I'm going to start at negative 6 and then go on forever, and a hard bracket goes around the negative 6. Now the range deals with the y values, right? So on the y's, I want to take a look at the lowest y value right here, because both ends go up, and this one is going to keep going up forever. I'm sorry, both ends don't go up, only the one does, the right side. So the right side keeps going up forever, so I know the range is going to go up forever. But where does it start from? What is this lowest y value right there? And that point, so 1, 2, 3, the lowest y value is 3, or negative 3, and the x value for that point is negative 4. So the coordinates of this point right here are negative 4, 3. That we're going to need that point here in a moment. All right, so the value of the range, or the range of the range, that goes from negative 4 all the way to infinity, and since that point is included, that y value, it would also have a hard bracket. Now for part C, they're like, hey, is g of 4 negative or positive? So g of 4. So I've got to figure out g of 4. So 4 is my x value. So if I go over 1, 2, 3, 4, and down to here, that spot right there, my y value is negative. So g of 4 is negative. All right, easy peasy. So you're just looking at the sign of that from wherever that point would be on the graph. Now, for what value of x does g of x equal 1? Does g of x equal 1? So where g of x equals 1, so g of x, that's like saying, hey, this is the same kind of thing as saying like y equals 1. So if I were to draw the line y equals 1, going all the way across, it looks like right there at that spot, right here at this spot, and over here at this spot. So at those three x values, the y value would be 1. So let's go from left to right. So on the left side, we would have x would be negative 5. Going to the middle, we have x equals 0. And finally, last but not least, we have, what is that? 1, 2, 3, 4, 5, 6. So x would be 6. So the x values where g of x equals 1 are the values x equals negative 5, 0, and 6. Now sometimes you might see it written like this, where you just put a little curly bracket. It's called a brace. Negative 5, 0, and 6. So you could see it written like that as well. Now for E and F, again, it's going back old school, Algebra 1, X and Y intercepts right there. So nothing that major, but we are going to take a look at that. So the X-intercept, 1 is, so I'm going to highlight it here in orange, 1's right there, 1's right there. So those two values, and we'll put the Y-intercept on there too. So the Y-intercept is that spot. So when I look at these values going across here, so the X-intercept is at negative 3, 0, and the other spot is at positive 3, 0. So those are the two coordinates for my X-intercepts. My Y-intercept is at 0, 1. So all of those are the values for my X and Y intercepts. Moving on to G and H, increasing and decreasing. So for this piece, this is where we kind of want to look at our slopes. And you have two types of slopes, right? So when you want increasing, the slope is going to be positive. So we're going to be positive slope right here. We're also going to have a positive slope kind of on this part right here. And then we're going to have a negative slope along this region. So decreasing, so g of x decreasing. So that's going to be from right here. We've got decreasing. And I've got some decreasing right there. And this other part, it's kind of hard to really tell. So you might have a little bit of flexibility here, but let's just say this starts decreasing right there. All right, and the increasing part, say we're going to go all the way here to 0, and then we're going to take that. So they're going to switch off, if you will, right there at x equals 0. So the slopes or be positive and negative on those spots. And if you kind of take a look, you know, if I were to draw a positive slope along the blue part right here on the left, check it out, see, so that would, we can see that's positive. Now, if we went a little bit closer and it's like, oh, right here, well, we could still be positive and still be positive, although not that much, and then eventually it kind of changes off. So, you know, there might be a little bit of flexibility there, but for the sake of this video, we're just going to use that. So the increasing part, it's like, oh, no big deal, we got that. Now remember, increasing, decreasing, always use the x values and always use soft brackets. So the x value where we're increasing is going to be from -4 all the way to 0. And then there's another spot, so we put a little union right there, that little symbol. And then we're going to go from, what is that x value? So 1, 2, 3, 4, 5. So this is 5. I'm going to write the coordinates here of this other, the y value here, because that looks like that's -2, because we're going to need that in a little bit. So we're going to go from 5, and then it goes on forever to the right. Now the decreasing part, all right, so we're decreasing. Now this is where you got to be careful, because on the left side, notice, the highest y value right there is at 5. So the x value at that spot, so we're going to start at -6, so that's where you got to be careful. Don't make the mistake and go, oh, negative infinity. So that is from -6 all the way to -4. That's one decreasing spot. And my other decreasing spot is from 0 to 5. So those are the two intervals where our function g of x is decreasing. So hopefully you're doing all right with this part right now, and we're good to go. Now for I and j, we're looking at the intervals where g of x is a greater than 0 or less than 0. So I want you to write this down. So g of x being greater than 0 means we're looking for that spot above the x-axis. So where is the function above the x-axis? The other thing we're going to look at, for g of x being less than 0, we're looking at below the x-axis. So these are the two areas that we are going to be concerning ourselves with. So when we look at this function, so I'm going to raise some of the highlighting here and change colors, maybe. Here, there we go, there we go, we got these pieces. So above and below the x-axis, all right, that's going to be this part right here. So anything that's above the x-axis is going to be right here. So this part of the graph, blah, blah, blah. And then there's going to be pieces below the x-axis. So right here, that's below the x-axis. Actually, let me redo that because I want to just draw the parts of the function that involve that. So this piece right here is above. This piece right here is above. And this piece going on forever is above. And then the below part is just right in here. And then also a little chunk right in there. So you can kind of see the parts of the graph that are above or below the x-axis based on the way we've got it highlighted there. Then we just have to give the intervals, much like we did for increasing and decreasing. Now the parts that are above the x-axis will go from -6 to -5. So that's that first piece. And then the other piece, I'm going to call this piece 1 right here just so you can kind of notate that. The second piece that we're going to have is going to go from -3 all the way to +3. So -3 to +3. So that's my second region. And then I've got this third region right over here that starts at 6 and then goes on forever. So that's going to have one more region from 6 to infinity. Now the parts that are in orange, that I've highlighted in orange, so those are going to be the parts that are below the x-axis, right? So if we look at those values, those x values, which are also, you know, you've got your x-intercepts there as well. So my x-intercept on the left side, so I'm going to call this one region 4. Right here, and sometimes you'll see that, you know, you might see it written like this, or maybe on the outside, and it's going to be region 5 right there. So those are going to be my two regions of my curve, my function below the x-axis, and that's going to go from -5 to -3 for the first part. So that's region 4. So -5 to -3, and then I'm going to also go from, let's see, what value is that? 3 to 6. So those are the two regions, the two intervals, where my function is less than 0, or my function is below the x-axis. All right? And then we're looking at our final two questions. Oh, no, we got 4 more. Oh boy. Long one, sorry about that, but that's the way it goes. How many times does y equals -1 intersect g of x? So if I were to draw the line y equals -1, so I'm going to draw that. I'll use this color. So -1 is right here, goes all the way across. Actually, I'm going to use red just so it sticks out a little bit more. So if I were to think about that, y equals -1, how many times does it cross that? So here's 1 right here, 2, and then 3, and then 4. So that crosses the function 4 different times. So my answer for that is the number 4. And 4 is cosmic. You can take any number, break it down, and it'll get to 4. Cool game. Now, local min. And is there an absolute min? So we'll take a look at these. Local min means I want a minimum value so I want the bottom of a hill. And I'm going to look at, I've got 2 bottoms right here. So if I look in region 4, I can look at that spot, and there is nothing lower than that. So that is going to be my absolute min. But this other spot at the bottom of region 5, that's going to be my relative min. And we can abbreviate absolute. Sometimes people write that as abs, you know, that's very common, and it's okay if you do that in this class. So absolute min is going to be at -4, 3, and the relative min is going to be at 5, -2. Now, when you list, so there's 2 things. One is where does it occur? So if it ever asks you where, you would give the x value. If it asks you for what is the min or what is the max, you give the y value. And the way this is, it says what are the local minimum. So local minimum, you know, I'm going to go ahead and give both of these for local minimum, because then I could specify them as being absolute or relative. So those 2 points, the local minima, one is at -4, -3, and the other coordinate is 5, -2. But in part n, it says what is the absolute minimum. So what is the value, the y value of my lowest part on the curve, and that's at -3. So the absolute min is just -3. Now our end behavior. So let's go end behavior. Now the end behavior on the left side, so this is going to be a little bit different, because notice on the left side, so let me zoom in here on the left, we only have part of the graph. Like, it doesn't go up forever, but we do approach this point, -6, -5, from one direction and one direction only. We approach it from the right side. Like, there is no, so I'm going to highlight it in, let's see, we'll go green. There's no part of the curve that's over on the left side right there that I've just shaded in green. There's no left side of that. So we're only going to approach from the right side. So when we write that, the left side end behavior, we're going to write it as this. So the limit as x approaches -6. Now, since we're coming from the right, we're going to denote that with a little plus sign as an exponent, because there's nothing on the left side of 6. So that's why we got to specify this. So a little bit new notation on that. And then our function, so again, be careful here, g of x. So that's talking about, you know, our function g of x. So the left side, now that gets all the way up to the point, to the y value of 5. All right, so the end behavior, on the left side, that goes all the way up to the point -6, -5. Now on the right side, notice the graph goes up forever. So it'll go up forever, and the function keeps going to the right, you know, so our x values keep increasing, and our y values keep increasing. So we'd write that as x approaches infinity of g of x, and that value, since it goes up forever, would be infinity. So that is the end behavior. So that's the rest of our notes on analyzing and interpreting graphs about all those key characteristics. All right, that's it for this video. Thank you guys so much for watching. Hope you have an amazing, magical day, because there's simply no good reason not to. And I'll catch up with you soon. I love you guys. Peace out, Cub Scouts.